Hi, so in this video we're going to continue on from the concepts from last lesson about sketching polynomials, but just with an extra element added in. So they'll be slightly more complex, but still going to be following the things like looking for y-intercepts, looking for roots, and looking at the leading coefficient to identify whether it starts up the top right or the bottom right. So I'll just go through the questions on the side, and I think that should be sufficient as I explain them as I go. So for question 1, we've got this polynomial which should look familiar, like a quadratic, and like before, if it's not in a factored form, it'll be difficult to find the roots, so we want to factorize it. So here you might recognize this as a perfect square, but if you didn't, your first approach might be doing PSF, and then if that fails, use the quadratic formula. So you'd get minus 1 times minus 1 is 1, and that adds to negative 2. So something times itself is x minus 1 squared. So the roots are when the polynomial equals 0. So when does x minus 1 squared equal 0? Well, only when x equals 1. We also want the y-intercept for graphing. So when we sub in 0, we get, we can do it into either 0 minus 1 all squared would be negative 1 all squared, which is 1, or you could have substituted it into the original expression. So 0 squared minus 2 times 0 is also 0, plus 1 is 1. Okay, so it's a degree 2 polynomial, so it'll have one turning point. So we have x-intercept here at 1, and we have a y-intercept here also at 1. Now, if you were graphing it, you might think it goes something like, it's a bit unco, but right, that would be a polynomial, but notice it has 2 roots. But when we solve the equation where p of x equaled 0, we only got one value. So notice how we only got one value, x equals 1, and where did it come from? X minus 1 squared. So you could almost say, if we sub this expression in, well, when does x minus 1 times x minus 1 equal 0? Well, when x equals 1, and also again when x equals 1. So instead of the 2 roots going 1, 2 on the parabola, it's kind of like both of the roots are packed into that one point. So it cuts the axis, cuts through it, and then instantly cuts back through. So it's essentially bouncing off the axis, right? So because it's positive x squared, it'll start up top right. It'll come in and bounce off the axis. And go up like that. Right. So you might have already been able to graph that by just considering it as a quadratic that's been shifted across by 1. But the reason I wanted to go through it this way is for when there's a polynomial of higher order. So for example, in question 2, where we've got x and x minus something all squared, so that's when you expand that all out, it's going to be x times x times x, it's going to be x cubed, right? But the point is, with the x minus 5 all squared, the same thing will apply. There's going to be what's called a double root there, where it's going to go and do this bounce kind of behavior, right? So we'll write out all the steps again. So this one's already factorized for us. So when does p of x equals 0? It might be good to write it out like this: x minus 5 times x minus 5 twice. So the roots are this equals 0 when x equals negative 1, when x equals 5, and again when x equals 5, because maybe writing it out twice might get in your head, oh, it's a double root, so it's going to do the bounce off, right? Either way is fine. You can just do it like I did above and write it, oh sorry, I ended up writing it twice, but write it once, or you can write it twice, but look at where that that power is, okay? Just also something else to note with the power is that this square power is only applying to this second set of brackets, right? This isn't x plus 1 times x minus 5, the whole thing squared. This is x plus 1 times x minus 5 all squared, right? So the squared's only attached to the factor x minus 5. Let's go grab the y-intercept as well. So we got 0 plus 1, 0 minus 5 squared, which is 1 times negative 5 all squared, will be 25. Okay, so what have we got? We've got our roots are at negative 1 and at 5. We've got our y-intercept at, this is going to be out of scale, but I'm not going to fuss too much about the where the turning point is, whether it's to the left or the right of the y-axis. You could figure that out, but we're just trying to emphasize the multiple roots here at the moment. So because if we expanded this out, we have x times x times x, so positive x cubed. We're going to start up the top right. Now 5, because it's a double root, right? When we get to 5, we're not going to cut down through the axis and come back up. We're going to come and then just bounce off the axis. It's a degree 3 polynomial, it's a cubic, so it's going to have a second turning point, and then it's going to come down through our y-intercept and through our other root there. Or it might have gone up and then gone through the y-intercept, then turned around and came down through the root. It could have been either one. Not sure which one though, but the key point is here that the x minus 5 all squared ends up becoming this little bouncy type thing. Okay, next one is a degree 3 polynomial, so it's going to have 2 turning points and a maximum of 3 roots. However, it's not factored, so it's hard to figure out the roots just by looking at it. So we want to look at the constant term, positive 8. So what factors could we use to get 8? We could get 1 and 8, 2 and 4, negative 1 and negative 8, or negative 2 and negative 4. So we'll do a bit of trial and error. Probably 1's a good place to start. P of 1 is 1 cubed minus 2 times 1 squared minus 4 times 1 plus 8. So that's 1 minus 2. Minus 4 is negative 5 plus 3 is 3, so that's not 0. So that if we're trying to use factor theorem, that means x minus 1 won't be a factor. Let's just go along, try the next number, 2. So we've got 2 cubed minus 2 times 2 squared. Oh, that's looking good because that's 8 minus 8. Minus 4 times 2 is 8, and plus 8 is going to be 0. Right, so when we substitute 2 in, there's no remainder, so that must mean we can conclude x minus 2 is a factor of p of x. So now we're going to have to find the other factors by doing polynomial long division. So we'll do x minus 2 into x cubed minus 2x squared minus 4x plus 8. Alright, so x we need to multiply by x squared to get x cubed. X squared times x is x cubed. X squared times minus 2 is minus 2x squared. Oh, that's nice. When you subtract them, they cancel out. So I guess we can bring both of these guys down. What do we need to multiply x by to get negative 4x is negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 2 is plus 8. And same thing, subtract it. You get 0. So that means our polynomial is x minus 2 here times x squared minus 4. And now x squared minus 4 is a difference of two squares. So there's our x minus 2 staying there, but then x squared minus 2 will factorize as difference of two squares. Square root of x squared is x, square root of 4 is 2, with a minus in the middle and a plus in the middle. And now here we've got x minus 2 times x minus 2, so we've got x minus 2, the whole thing squared. Okay, so let's find our intercepts. When we put in 0, if you put it into this expression, so because it's already expanded out here, right, when you put in 0, 0, 0, you're going to be left with 8 there. And this guy here, the polynomial in factored form equals 0 when x equals 2, when x equals 2 again, or when x equals negative 2. So that means there's going to be a double root there. So if we graph this, we're going to go through 8. 2 is our double root, we're going to bounce off. And also, remember here it was positive x cubed, so it's going to start on the right side, it's going to start up the top. So 2 is a double root, so we're going to come down, bounce off, turn around at some point, and then go through there. Alright, so all three of those questions had one of the factors was squared, right? And when it's an even power, like squared, it's going to have that kind of the multiple root is going to bounce off. So in the next few questions, there's going to be a different kind of behavior when it's an odd power. So for question 4. Hopefully this is just a refresher that what x cubed graph looks like. So x cubed comes down here, curves around, and looks like that. So if you've forgotten that, you could draw up a table of values when x equals, say, negative 2, negative 1, 0, 1 and 2. Find the y values, and they'll kind of go here, 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 and here. And or you can do something like graph it in GeoGebra. So this here we could have thought of as the polynomial is x minus 0 all cubed. So it's something factored, x minus something all cubed. And notice here where 0 is, so what would make the polynomial 0? Well, when x equals 0. Here at 0, this is now like kind of like the double root. There's kind of like 3 roots all packed into here at one point, right? Notice this doesn't just kind of, it doesn't kind of decrease and then kind of just cut through something like that, right? It kind of has this little little swervy bendy shape, right? Where here it's increasing and then it kind of curls around and then it keeps increasing like that, right? So when we have an odd power, so for example a triple root, or you can extend this to a fifth quintuple root, and I don't know the exact terminology there, then it will have this, so any odd power will have this kind of little swervy thing happen, right? So when we do question 5, sorry. Okay, so let's find the y-intercept is negative 0 times 0 minus 3. This will be 0. Okay, and when does the polynomial equal 0? When something x times x minus 3 cubed equals 0. So here either x times all this, so if this x here was 0, that would make the equation equal 0. Or if x equaled 3, 3 minus 3 would be 0. But you've got a 3 there, and then because this happens 3 times, you've got 3 roots all packed into the x value of 3. What about the sign of the leading coefficient? Well, if you expanded this all out, you'd get negative x times positive x 3 times positive x, which would be negative x to the 4. Right, so it's a quartic, so it's going to have up to 4 roots, so where it's got 3 packed into one point, 4 roots, and it's going to have 3 turning points. Okay, so we've got one of our x-intercepts is at 0, and also our y-intercept is 0, so they're going to cut through there at the origin, and then our other point is 3. Actually, I'll do it below. So because it was negative x to the 4, right? It's going to start on the right side down the bottom. So we're going to start down the bottom, and then when we come through this point here at 3, it's going to be a triple root. So it's going to have this same kind of curvature of this cubic x cubed up here, but it's going to be the same thing but flipped over, right? So it's going to come up, curl around, kind of just skim through the point, and then curl around and keep going up. So that's like a kind of like an x cubed graph, and then it's going to have another turning point, and then come back through that point there and there. So just some other things to think about here, which didn't happen before. So when we had something all squared, notice it bounces off. So that's only really one turning point. Even though it bounces off and it's 2 roots at that point, it's only one turning point. Okay, so the difference here is, remember I said a quartic function, right? X times x times x, x times x times x times x is an x to the 4, has 3 turning points. So notice here, this is obviously one turning point here, turns around. So when you have this cubic here, this is what's called an inflection point. And kind of like how the bounce off the axis is 2 roots in 1 point, and this is 3 roots in the 1 point. This is kind of like 2 turning points at the 1 point, right? Kind of equals 2 turning points, right? See here, you increase and increase, hit the turning point, and turn around and decrease. But here, when you're coming and approaching 3, you're decreasing, you go through the point, and then you turn around and you keep decreasing. So if you kind of visually blocked off the right, and just looked at the left of that box, right, it kind of looks like the left half is like a parabola. It's coming down and it's coming about to turn around. And then if you now ignore this left bit and you look to the right, that also looks like a parabola where it's kind of turned around. So it's kind of like two turning points packed into that 1 point as well. Okay, last one here. We've got 6 is x plus 2 or whoops. Polynomial is x plus 2 all squared, x minus 4 all cubed. So here we've got how many lots of x? X times 2 times here, so x times x, and then in the second set we got times x times x times x 3 times, so altogether this is a quintic, x to the 5. Okay, so it's going to have 4 turning points and up to 3 roots. So what's the y-intercept? We've got 2 squared times negative 4 cubed. We're not going to be drawing this one to scale. 4 times 64 is 256. And where are the roots? Well, we've got x equals negative 2. So that one's going to be a double. We've got it twice. And this is 0 when x equals 4. And we've got that there 1, 2, 3 times, right? You can use any kind of visual tool that makes sense to yourself. Okay, and it is positive x to the 5, so that means on the right side it's going to start up the top. Okay, so we've got intercepts at negative 2 and at 4, and all the way up here at all that way up, 256. I think that's actually shorter than the distance to 4 on the x-axis. So if we're starting at the top right, and what's the behavior at 4? 4 is a triple root, so that means that we're going to come around. Hold up, I seem to have done something wrong. Sorry. Negative 4 all cubed. That's right. Okay, that piece was right. 2 squared is 4. Negative 4 all cubed will be a negative. So this will be negative 256. Okay. So it's a positive, the leading coefficient is positive, so it's going to start up the top right. 4 is a triple root, so it's going to come through as an inflection point, right, and curl back down. Then it's going to turn around at some point, whether it's to the left or right, and cut through this y-intercept. Now when it comes up to negative 2, negative 2 is a double root, so that means it's going to come up and bounce off the axis like that. Right, so obviously not to scale with how far down the negative 256 is, but that's kind of like the curvature and what's happening at at the roots there. Alright. So just as a little summary, right? So when you've got a polynomial is x minus, I'll use alpha for a root, to the power, I won't use n, right? So this times something else, right? So notice there's no remainder there, so this is saying we've got x minus 5 or something all cubed times the other factors, right? What this value here does graphically is it'll do a bounce if it's even. So just like if it was x minus 5 to the 6, it'd do just like the parabola. It would bounce off, and it would do the, I don't know what you want to call the little swervy thing. It'll do, that seems good enough. It'll do a swerve if it's odd, right? So just like the cubic, if it was x minus 6 all to the power of 19, then at x equals 6, at that root, it would do a swerve like that. Alright, that's all for this video. Bye.